Hi students, today I would like to share with you about computer and seismic data, basically on how the seismic data are being recorded and the storing of your seismic data, because I realized that before we should start with the data loading and so on, all students should know the format of this data, basically for a seismic data set. As you know, we have 2D and 3D, so both 2D and 3D, both 2D and 3D, the recording and the storing will be the same. So for this lecture, the objective will be that you will be able to list two types of data exchange formats that are commonly used today. You will be able to identify the primary use of each format, and then you will be able to describe and find information from the headers of this format. So as you can see, this is a tape. This is a SEC-Y tape with all the labels, and this is where we store our seismic data. But nowadays we can also store it in just a normal hard disk. So we have two types of exchange formats. The first one is SEC-D headers. As you can see here, these SEC-D headers typically records the field data straight away from your acquisition. This is the format when the data is sent to the processing companies such as CGG, Western GECO, PGS, and so on. So to process the data, the processing company will have to change this data set from SEC-D format to their internal format. This internal format is variables depending on each processing company. The process of changing from SEC-D format to an internal format is known as a reformatting step in processing, seismic data processing. So I won't go in details for seismic data processing because that is when you take your major in geophysics when you go to 4th year. Basically, this is examples of, please follow my mouse arrow. So this is examples of short records from land data where you can see these triangle shapes, and this having a first break. So I believe you have seen this during your seismic method subject. So in one short point, we have a general header, extended headers, scan type headers, intra-block get, and some trace headers. So this is for both marine and land data. So I'm showing here is the example from land data, and here is SEC-D headers from marine data. It shows from marine data it has this near, mid, and far recorders. So this is where we have a tape header. In one tape we can have few short records, the record headers, and then we have a trace header, and then we have all the seismic wiggles, the seismic data being stored inside that. So this is for SEC-D data. Apart from SEC-D data, we also have a SEC-Y format. This is the format that you guys are going to use as a seismic interpreter. It is a standard format that we receive after the seismic data being processed. This is where the processing center will send it to the client in this format, and this is the data that you are going to use, as I mentioned earlier. So what we have in our SEC-Y header is we're going to have an abscisic reel header. This is showing the general information that an interpreter should know. Who did the acquisition, when was the acquisition was done, what are the line numbers, the coordinates, the recording parameters, the processing parameters that have been applied to your data. After the abscisic header, you're going to have a binary header or a trace header. This is where you have your information in your seismic data, such as where is the information of coordinates, information of the static, information of your CDP, information of your inline, coastline, and so on being stored in the computer or in the system. So I would like to show you example of an abscisic header. This is, you can see this is examples of an abscisic header from showing the client was Petronas Carigalis Sdn Bhd, showing the inline numbers. This is the range of inlines, means in the total of this seismic data, the seismic data have a total of 1,600 inline. So if you would like to know how many inlines in your seismic data, you can just use this one. Minus 980. So this will be the total number of your inlines, and same goes to your total number of crossline, where you can minus the largest number to the smallest number of your crossline. So apart from that, you can also know what is the area. The area was in Sepat and Lahore field. So this is actually a confidential data, but for the sake of educating you guys on how to read your biapsidic header, I'm sharing this with all of you. So the recording instrument or your hydrophones that was used was this model, Syntrack 960-24 system. The format of recording was SECD blah blah blah, and this is showing that how much is what is the short intervals, source flip-flop, and having 2 source arrays, the acquisition date, cable length, for how many streamers were used, and how many geophones or how many hydrophones in one streamer, what is the group interval, the total record length is 6,500 milliseconds, sample rate was recorded in 2 milliseconds, and this is the most important information, which is the byte locations. Byte 189 to 190 contain this byte location, while inline was in byte 189 to 190 is inline, where they stored the inline numbers. So all these numbers are stored in this byte position. So this byte position is related back to the storing of computers, the data in computers. And then we have byte 191 to 192 that stores our crossline. Our x coordinate was stored in 73 to 76 and y coordinate in 77 to 80. So as you can see, in the we have 189 to 190 for inlines. So we have 2 bytes. This shows that we are recording in 2 bytes. 2-byte system. We can also have recording in 4 bytes. So this apsidic header is not the same for, it's not unique. It is unique actually for different data set. Means if you have data set from let's say Anding from Malay Basin, the apsidic header will be totally different from what we have seen here for areas Sepat and Lahore. If you have data set from Mexico, it will be different, definitely, because these all apsidic header and the byte locations and so on, this reflects is very unique for each data set, because it is based on how the processing company process and store your seg-y. As you can see, this is example of apsidic header. I'm going to show you examples of trace header. So this is using SeisView or Seismic software, where you can just download it for free from the internet. You can load your data set. So I'm having here examples of Sumandak data set where I have cropped it. So you can see this is the text header or the apsidic header, where you have the total number of inline, total number of crossline, the coordinates for x minimum and x maximum, y minimum and y maximum. You can also see that this helps you to find the location when you're trying to load your data set. Examples in Petrel, you need to know what is the byte location for your inline and crossline. As you can see here, showing inline number is in bytes 5 to 8. So 5, 6, 7, and 8, it includes 4 spaces. So this is 4 bytes recording. whereas the one that I'm showing just now in Sepat and Lahore was in 2 bytes position. So apart from that, we can also have a bin header or trace header. So this is a trace header. As you can see just now, trace sequence number with reals is 528 bytes, which is referring to our inline number. This is where we need to store our X and Y coordinate. And this is examples of our data. The seismic view of it, as you can see. So this is the wiggles. The wiggles look alike, where we have a positive and negative side. So I'm zooming in, you have a positive and also negative. Alright, so that's all for your information about seismic data recording and storage of it. So once you are going to load your seismic data in Petrel during your lab, please check on this information. Okay? And you are going to put these numbers, the bytes location, so that the computer can read the information for your inline, for your crossline, coordinates, and so on. So I hope this video will help you in understanding how to read your seg-y headers. In general, we call this as a seg-y headers. With that, I hope that you will be able to identify and differentiate between seg-d and seg-y, where in Petrel we can import seg-y because seg-y is the one that we are going to interpret. Seg-d is straight away raw from the acquisition. So with that, I would like to say